Let's add a fluid to our block entity. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. In previous episodes, we developed our user interface, and I will change that user interface in my free time because I want to utilize the power of drawing two separated panels, one below the other one, for just showing beautiful interfaces. However, in that video, we didn't have the fluid, and we mimicked the fluid by having temporary tank on top, as you see, and then transactioning some fluid here. I will talk about all of this from this video forward, so don't worry about it. However, this was a temporary solution to show you that we can put some fluid inside our fluid widget. For fluid widget, we have to set a tank, we have to supply the position for the tank, and if you don't have a tank, it can't read the amount and capacity and the type of fluid, anything like that. Because of that, we had to set this tank up here, and now I will nuke it, and yes, we will have an error here. I'm aware of that. We will come back into our block entity and we will fulfill another to-do that we have here. Right now, we added our GUI, we added our inventory, so I just removed these to-dos from top, and the next one is the fluid. Before I start coding, I need to explain things to you about fluid inside Minecraft. First of all, fluid is provided by Fabric API and not the Fabric loader. Fabric API is a separate modular library that almost all the mods are using. So whenever you are modding Minecraft using Fabric, the very first thing that you will always install is the Fabric API. However, the Fabric API introduces fluid in a very complex manner. I'm not sure if it's needed or not, but understanding it is really important. A fluid has three different elements. Actually, let's say it this way. We have a fluid and we have a fluid view, a storage view, okay? So let's talk about the fluid itself. A fluid has two different compartments. One is the fluid type. Now, the fluid type in Fabric API is called variant. So we have a fluid variant. The fluid variant can be, for example, water or lava or anything else. Then each one of these variants has ability to go into a storage. So this will be a storage. Now, keep in mind, we are just barely scratching the surface because it's way more complicated. For example, fluids can have fluid attributes, and those fluid attributes can carry heat, but by default, water and lava are not carrying any heat, and we don't have any default heat API in the Fabric API. I'm just barely scratching the surface. Each fluid variant can sit inside a variant storage. Now, variant storage can be a single variant storage or multi-variant storage. A single variant storage can carry only one type of fluid. A multi-variant storage can carry more than one type of fluid. So a storage will have two things now. Of course, it needs to know the variant. So it needs to know if it is a storage of water or anything else. However, it needs to carry around another thing, and that is the amount of the fluid. Okay, now you may think that having a variant, having an amount, especially if you follow these videos very carefully, you will understand that it's close to what we have as fluid stack in a record. However, that's not the only thing the storage has. The storage will have much more things, and when we go into that, we will take a look at different things like the storage can accept fluid, it can lose fluid, and it can accept fluid, it can export fluid, and many more things there that needs to happen in between. Keep in mind, there is one more name that you will hear from me, and this one is a little bit bothersome, and that is storage view. Now, we didn't have this one in the item storage, but for some reason that I don't understand, when it comes to fluids, we will have this storage view, and when we want to retrieve the variant, the fluid variant from a storage, we need to go into a storage view and take a look at its resource. So the namings on the fluid API are a little bit confusing at times, but don't worry, we will handle each one of them. Now, the second thing that you need to understand is that every transfer system inside Fabric is push base. What does it mean? Let's say that we have a container here and we have a container here, and we want something being transferred from this container to this container. It can be item, it can be fluid, it can be energy. Later on, when we have the library for anything else like gas or pressure or I don't know, any other thing, heat, it can transfer something from the container named A to container named B. Now, there are two different solutions for this. One solution is that the container A will be responsible of finding container B and sending the thing toward container B. Basically, it is pushing out whatever it needs to. So container B doesn't know where this thing came from. It will just accept whatever came and says, okay, I got a gift. I don't care who gave me the gift. Give it to me. The container A is the decision maker that says, okay, container B, you get this gift or you shouldn't get this. This is a push-based system. Now we have another system in general, in theory, that is called pull-based system. In pull-based system, container B is responsible of finding container A, taking item out of it and put it inside himself. In this case, container A does not know where this gift is going. It will just give out the gift. But container B is responsible of finding this gift maker and taking the gift from him and putting it inside his own inventory. I'm not sure what was the reason for the decision making. All we know is that in Fabric, the transfer API is push based. Means that A is responsible of sending out the item. A is responsible of finding the B as the receiver. B doesn't care where it came from. It either can accept it or can't accept it. If it can accept it, then it will accept it. Now here's a question. Which one of these is better? The push-based or pull-based? Honestly, it doesn't matter. I think each one of them has their own downside and their own bright side. For some times in modding, what you want to do would make a pull-based system more user-friendly, but at other times, a push-based system would be user-friendly. So in an ideal world, you would have both of them. You would have a pull-based or a push-based. However, in Fabric, we don't have the pull-based system. The transfer API is dedicatedly push-based system. I will give you a theory of what you can do. If you want a pull-based system, I think in theory at least, there is another solution that works around this problem. Let's say that the container B needs to pull something to himself. It will look around itself and it will look and find A. Now, this is what you need to write the code yourself. Fabric API is not supporting it, okay? Now that it finds the A, it will call a method on A and it will provide his own position as the destination. For example, send energy and here is the blog post. So now the system in A will find a blog in this position and then using push-based system will send the energy back. It is doable anyway, and it's not that complex actually, and I think that's exactly why the Fabric didn't implement both ways, but it's up to you. So if you need a pull-based system, you need to be smart and work around the system. However, let's deal with the inventory itself, because right now we are not talking about transferring. That was just an introduction to the fluid system, okay? And later it's the same for the energy system. But right now, this block entity right now doesn't contain any solution to keep the fluid inside of itself. So we want to handle that before anything else. To do that, we need to add a fluid storage. Now, for fluid storage, we have three different solutions in vanilla by itself, and I will tell you what is the benefit of each one. We can say private, final, a single fluid storage. As we said, it's a fluid storage that can accept only a single type of fluid at a time, and we call it fluid storage. Now, we can simply say that it is a single fluid storage with fixed capacity, and here we will say fluid constants dot bucket. Now take note, as I'm typing it, I will stop. A bucket is a T1000. That's a confusing number, isn't it? I will talk about it in a few seconds. So let's just say that that we can accept, I don't know, 10 buckets, and then as you see, it can accept a runnable unchanged. This means that when the content or the amount or the type or anything about this fluid is changed, we want to call something. What should we call and when should we call it? In the block entity, we have the update method from our library that will mark dirty the block entity, and by doing mark dirty, it will at the same time call update listeners and things like that. So we just call this that colon update, okay? And every time anything in this inventory changes, it will change the client by syncing and marking the block entity dirty, everything like that. If you don't use our library and you want to go vanilla way, you can use mark dirty here, okay? So this is one way of doing it. A simplest, fastest, easiest way to read. However, it has a downside too. If you notice, it says with fixed capacity, means that we can't change the capacity of this fluid container later down the road in any shape, in any form, not using an upgrade, not even using multi-block system. No, this is a fixed size of 10 buckets worth of fluid, okay? If we want to be flexible, we should say private final single fluid storage, we call it fluid storage, equals to new single fluid storage. But as you see, I just hit enter. I'm not gonna use that with fixed capacity because this will force us to handle get capacity ourselves. Now here I can say, for example, it's equals to the fluid constants dot bucket multiplied by, I wouldn't say that 10 at the very least, plus, who cares, a fluid bucket worth of the fluid multiplied by this dot get, for example, fluid upgrade count. And all this method will do is it will look inside the upgrade slots and the index 2 and read the number of item stacks there. It will return it and it will be adjustable like so. For example, right now I can say that, hey, I have a private that returns integer that, and right now I will return 2. For example, I have 2 of them, okay? Oh, I cannot say this because, be careful, this here means the fluid storage itself. So somehow, yeah, I need to remove that this, and now we are talking about the block entity. If you want to, you can say that gem cleaner be dot this dot blah. This is all good, but if you leave it as it is, then it will not sync between the client and server, and it will not update NBT or anything like that. To do that, we need to override another method, and that is on final commit. Now we will talk about fluid transfer in another video, but sufficient to say that when you are transferring something using transfer API in Fabric from one container to another container, it happens in 2 steps. And the second step is finalizing that transfer. So when you are finalizing the transfer, you call the commit method, and that will call the on final commit on any container that has it. In this case, it's a fluid container. So here we don't need to call this on final commit on super, because if we look at that, it's an empty method. So instead of calling this super, if you want to, you can keep that super there, but instead we can just call the update here. And effectively now we have a container that in theory should be able to have more than the default capacity based on any item or any logic that you want to, and it will update and it will sync itself between client and server. Now, are we done? Are we finished? Really not. The very first thing that I need to add here is a way to get this storage out of the system, because right now it's private final. And take note, I'm not adding it inside the constructor because it's an inline initialized final storage. So we will say public, and it will return a single fluid storage. We call it get fluid storage, and it will accept nothing. Here we simply return the fluid storage. That's our accessor, that's our getter method, okay? Then we need to read and write to NBT, because if we don't do that, well, we are not saving the data for the fluid inside the NBT when we are closing the game. And when we are coming back to the game, it will initialize this fluid container and it will be empty because we are not reading any amount from the container. So we need to write to NBT and we need to read from NBT. So read NBT. I will keep the super as it is. Then we will say this dot storage, or in this case, the fluid storage dot write NBT. And that's it. This will write our fluid storage to the NBT. And here we can say this dot storage dot read NBT, and that will read from NBT. Now, this is all the things that you need to do inside the block entity. In theory, right now, this block entity contains a fluid container. It's not sided right now, but that's another story that we will come back to it later. Now, in a screen renderer, when we have this tank, we can simply say that, hey, we have the handler. The handler has this get block entity because this is an extension of our library, and this library is caching the block entity. And now we have that fluid storage, and that's it. We right now have the access to that tank dynamically in the game. So if I add anything at any time inside that fluid container, it will dynamically update itself on the screen renderer. We don't need to do anything as a screen handler. But if you want to make this fluid container being sided, means that it will accept things from cables, for example, or pipes, you need to do another extra step. And that is to come into our registries and block entities. As you see, we have added the inventory to be sided. We can simply say fluid storage dot sided dot register for block entity. Now here again we need to send in the class, and now we need to provide the method that will give us the fluid container, and that is get fluid storage. And then of course we need to give the block entity type, and that is gem cleaner as the type. And this line should make this thing sided in theory. However, you notice that we have a problem here. The problem is that the get fluid storage now needs to accept a direction. So we say direction, direction. And adding this, although we are not using it right now, we'll fix that error there. And now we can accept fluids from pipes or any adjacent inventory that will push the fluids toward us or anything like that. So right now, we have a fluid container. This fluid container has nothing in itself as we are speaking, but if we run the game, we shouldn't have any problem, and we should be able to open the GUI. The GUI will show up, and the container for the widget should be empty without anything in it. However, if we want to test that, we can simply do a transaction here again. The transaction will put, for example, a bucket worth of fluid inside the tank. To do that, I will do a try. And don't worry, we will talk about transactions later. Right now, I will just write the code and will not explain anything about transactions because that needs its own dedicated video. Bear with me when I'm doing this. So I will say we want a transaction, and we call it transaction equals to transaction open outer, and that's only the try. We don't need any exceptions there. So we say get the tank, and here we will say null, fix that error, because null means that every direction, it doesn't matter because we are not using it. So this is the tank. And now we want to insert something in it. The thing that we want is that right now we want a variant. So we say fluid variant of fluids dot water, and then the amount. So the amount will be a bucket of water. So fluid constants dot bucket, and then we want the transaction. We assume that it's successful right now, so we say transaction dot commit, and this commit will call on the final commit. However, we have a problem here. Let me see what we have here, an extra parenthesis. So this should put a bucket of water inside our container. Let's run the game again. This time, if everything works, we should see one bucket of water in a container, and the container actually should not be 10 buckets worth of fluid, but we are adding extra 2 buckets. So it will be 12 buckets of water, or in other words, 12,000 millibuckets. That takes us to talk about fluid constants and the difference between how Fabric is working compared to other systems like Forge and NeoForge. But let's see the result in the game and make sure that everything is working. Then we will come back and talk about that difference. The game is loading. That's a good sign. And let's go into the game. Let's go into the board and let's cross our fingers that when we open the UI, we will see a single bucket of water in a container that has capacity of 12 buckets. Well, we see the water. It's 1,000 from 12,000. Exactly what we did need to see. So our container is working and we have transferred fluid inside our container as much as we want, and we are looking at the capacity dynamically. So if at any time in the game I make it to 3, then save the game, load the game, it should work. And the write and read the NBT is correct. I don't need to test them because they are really simple. They are just calling the read and write to the Fluid API thing, so it would work. You just need to keep that in mind, that you read and write to NBT all the time. Now let's talk about this fluid constants. What is this? When you work with Forge and NeoForge, you would know that a bucket of water is actually 1,000 millibuckets of water. And that makes sense because a milli division means that you would divide the unit by 1,000. So a unit of water will be divided by 1,000. So a millibucket is 1,000th of a bucket. However, when we go into Fabric, we see this nonsense. A bucket is 81,000. Take note, it's still a multiplied value of 1,000. However, there is actually a history behind these values. There was a very long ongoing debating on how they should value these things. And the biggest problem comes from a bottle. A bottle of water is 1/3 of a bucket. Means that if I want a bucket of water to be 1,000, then I need to divide it by 3 to get a bottle. Now the problem is that 1,000 divided by 3 is not a valid integer. It's a float value. And we can't have floats as capacity of fluid tanks because they are long and they are accepting whole numbers. So in reality, what Forge and NeoForge is doing is wrong. And they have this problem regarding water bottles that they totally ignored. You know, they say that a water bottle is actually 333. And we know that if we multiply it by 3, we get 999, and it's not 1,000. So you are losing 1 millibucket of water. If you convert a bucket of water to 3 bottles and then back, it will not become a whole bucket. They ignore this. They totally ignore this. And I think they may have some shenanigans behind the scene in the code, in the core of the Forge and NeoForge to solve this problem. However, Fabric took a more sane way of handling it. They made the decision that we want to handle values that are capable of being divided by 1,000 and being divided by 3 at all the time. Now, here's another problem. If we have a fluid that we converted to an ingot, for example, molten gold and gold ingot, and then we have gold nugget, and that's where the things start. So a nugget will become 1,000 because, as we said, here's the thought process. A nugget is the simplest unit that we can have, but it should be able to become a milli thing, okay? A milli bucket, a milli nugget, and anything. We established the fact that we want all the numbers to be possible to be divided by 1,000. So 1 nugget multiple 1,000 will become 1,000. And that is this guy. Now we know that an ingot equals to 9 nuggets. So guess what? We multiply 1,000 by 9, we get 9,000 for an ingot. And that's the second value. Now we know that if we compress 9 ingots, we should get a block. So again, if we multiply 9 by 9, we get 81,000. And we know that a block of water is equivalent of 1 bucket of water. So again, we have the same value for the block and bucket. And as we established, a bottle is 1/3 of a bucket. So we divide 81,000 by 3, we end up with 27,000. And a bottle is equivalent to a bottle. Okay, we got these numbers. And the minimum number possible is 1. So we established the droplet. So each drop of water will be 1, meaning that if you establish a lava generating thing that will generate 1 droplet each tick, then we want 81,000 ticks to generate a bucket. Means that if we have a system that says 1 tick equivalent of 1 droplet, then a bucket equals to 81,000 divided by 20. Now you see where these things shine, because now we know that we can convert this to be 8,100 divided by 2. So we can divide it by 10, and we are still ending up with even number. So it will be 4050 seconds. And if we divide it by 60 seconds, 4050 divided by 60 seconds, we end up with around a minute and less than 10 seconds. So that machine will produce 1 bucket of lava each minute. This is where these numbers come from and where the system of numbering in Fabric shines. Basically, you can go as little as a single drop of a fluid and go all the way in every possible scenario. So you make it 1,000 drops to get a nugget, then 9 nuggets to an ingot, 9 ingots to a block. 1 block is a bucket, and 1/3 of a bucket can be a bottle or a bottle. And these numbers are really making sense now. Problem: if you follow Cup and Joe's tutorials, he says that do this. Instead of 1 bucket of fluid, get 1,000 millibucket, and then use 1,000 here as millibuckets. Well, that may work as long as you are not interacting with anything else other than yourself. Means that if you are a single mod on a single server, this system will work. However, the moment you play on a game that has multiple mods and each mod containing its own fluid and they are handling fluid transfer, this will become a headache, because now you have a problem. For example, a cable will try to send in, for example, a bubble worth of fluid by other mods. Now, we established the fact that it will be 27,000, okay? Let's write it up. A bottle, for example, let's say it's 27,000, okay? Now, the pipe is trying to transfer this amount of fluid into your tank. However, your tank is designed to have 3,000 units of fluid. And even worse, let's say 30,000. Now, this is better, because if you go with 3,000, the transfer will fail and nothing bad will happen. But if your tank is designed to have 30,000, you'd think that it will make 30 buckets. However, now the pipe will successfully transfer 27,000 into your tank if it's empty. The pipe was transferring a single bottle, 1/3 of a bucket. But now you have 27 bucket of fluid, because in your tank, what you will see is this 27 multiple 1,000 milli buckets. It will be translated to 27 buckets. You see the problem here? And this is something that I wonder, why did Cup and Joe doing this? Because if it comes to the tooltip, well, guess what? It's easy. You can divide a bucket by 1,000 and you get the value of a millibucket, that is 81. And then you divide the amount by 81 and you get the units of millibuckets, and you show that value. As you see, we are doing in our GUI. If I go into our widget, and if I go into the fluid widget, and if I open that draw tooltip, you see that what I'm doing here is I'm dividing to bucket and then multiplying by 1,000. This will convert the amount from the Fabric to millibuckets. And that's it, because 1 bucket divided by 1 bucket will become 1. 81,000 divided by 81,000 will become 1. And then we multiply it by 1,000. So we ended up with 1,000. If it's 27,000, so a bottle divided by a bucket, we get 0.333, and multiplied by 1,000, we get 333 millibuckets. So if it comes to drawing the tooltip, this is doable. available. So why should you derp so much to open the door to this problem by just using 1000 here instead of the standard units inside Fabric? This is why you see that people who followed Cup and Joe's tutorials, every now and then, when they finish their mod and they start playing the game, they scratch their head because some things are not working. This is one example of it. And there are other places that he is giving false information. This is the one critical thing that you need to fix, and that is don't use any arbitrary number from millibucket system. Ignore that. The widget will handle it. The screen renderer actually should handle that. The system should still work with fluid constants to follow the standard unit. And exactly that change in Cup and Joe's code shows up his face when he wants to transfer fluid around. For example, from a bucket to a container. Now he needs to constantly go back and forth, converting from standard units to millibuckets and from millibuckets to standard units. And that's a headache. And every time you try to do this in your mod, you open doors to bugs. Instead, stick to the Fabric standards. And then, as you see in my screen renderer, when I'm transferring a fluid, I don't care. I just say, drop one bucket of water into my container. I don't need to transfer it back to millibuckets so that it will be compatible with my mod, because you know what? Other people will not do that. If someone else is writing a pipe and a player, a very good player like, I don't know, Direwolf, for example, tries to combine 20 different mods to each other and he makes the decision that he wants your mod, well, guess what? He may use another pipe from another mod connected to your machine, and the fluid generator comes from the third mod, and all of these need to handle things correctly and talk to each other in the game by a user, by a player that has no knowledge of coding at all. In that scenario, guess what? He's sending one bottle of water and suddenly he sees 27 buckets of water in his container. He will not be happy, I'm telling you. So bottom line is that the screen renderer should handle the conversion in the draw tooltip, nowhere else. Your block entity container should handle the standard way of Fabric for the capacity or anywhere else that you need to transfer fluids. That is all for this video, and I hope that now you understand why it's 81,000 or anything else. If you want to, you can have a millibucket constant somewhere. For example, in your block entity, you can say private static final millibucket equals to, now it's easy, get the bucket divided by 1000, and that's the integer here, and that will be 81 actually. Now here's the problem, this will be long, so the result should be still long. Okay, if you want to be an integer or a short, the result is actually 81, so I think you can even keep it as a short, or I don't know, a byte will go up to 255. It's usable by all of that, so that will be your millibucket. But I suggest that you still keep it as long, because every mathematic calculation on fluids will use long, and then you won't need to constantly deal with typecasts here and there. So that's a millibucket if you want. And why should you actually convert it to anything else? So if, for example, if you're adamant on using millibuckets, now you can use millibuckets multiplied by 10,000. And that means that, hey, I have 10 buckets. But as you see, to me, this makes much more sense compared to what people are doing. Anyway, in the next video, we will come back to the same class, and actually we will convert it so that it will use our library for the fluid, because we will have a connector for fluid storage that is already handling sided connection. Before closing the video, here's a question. What if you don't want to use my library and yet you want to be sided? For example, let's say that you only want to handle the fluid if the transferring is happening from below. Here, you can easily say that if direction equals to direction.down, then send the fluid, otherwise send null. The good thing about sided inventories and sided handling inside Fabric API's transfer system is that it can accept null, and it means that it will not accept anything or transfer anything by that side. And this way, you can easily make your fluid talk from the container in one special direction. But for time being, we will accept fluid from all directions, although in the next video, when we are coming back to our fluid connector, we will make it so that the fluid can come only from one side. If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video,
you will get informed. Have fun, everyone. Bye.